Hi everyone, welcome for today's class. Today we will discuss cells in series and parallel. In the previous class, we have learned the relation between EMF and terminal potential difference. When a cell is being discharged, EMF and terminal potential difference is related as V equals E minus IR. When the cell is being charged, the equation for terminal potential difference is V equals E plus IR. Now we use these equations and we will find the equivalent EMF and the equivalent internal resistances when two or more cells are connected in series and parallel. First, let us discuss cells in series. Consider two cells of EMF E1 and E2 and internal resistances R1 and R2. This is a cell of EMF E1. This is connected in series with a cell of EMF E2. Internal resistance R2. Okay. So the potential difference across this combination is V. You know, when resistors are connected in series, same current flows through all resistors. In the same way, when cells are connected in series, same current will be flowing through all the resistors. So suppose all the same current is flowing through the two cells here. See, this is the cells in series. Current is I. But potential difference divides. Potential difference across the first cell is V1. Potential difference across the second cell is V2. So the total potential difference across the combination is V. So we can write V is equal to V1 plus V2. Last class we learned the relation between V and E. V equals E minus IR. So we can put in this equation. V1 is E1 minus IR1 plus V2 is E2 minus IR2. So we can rearrange this as E1 plus E2, you group together, minus I into R1 plus R2. V equals, we rewrite this as E equivalent minus I into R equivalent. So what is the equivalent EMF of the combination? E equivalent equals E1 plus E2. And R equivalent is R1 plus R2. So when cells are connected in series, equivalent EMF is equal to the sum of the individual EMF. And equivalent internal resistance is the sum of the individual internal resistance. Okay. If this combination of cells is connected to an external resistance, what will be the current through the cell? Say these two cells are connected to an external resistance, capital R. Then what will be the equation for the current? Current will be, what is the equivalent EMF? E1 plus E2. What is the total resistance? External resistance is R plus equivalent internal resistance is R1 plus R2. Okay. If n identical cells are connected in series, what will be the current through the combination? So we are considering as a case. N identical cells are connected in series to an external resistor. What will be the current? N identical cells all have same EMF and all have same internal resistance. So what is the equivalent EMF? E equivalent will be E plus, E plus, E plus, etc. There will be N times. So equivalent EMF will be NE. What will be the equivalent internal resistance? R plus, R plus, R plus, etc. So it will be NR. Now you can find out the current. Current will be NE divided by R plus NR. So remember, when cells are connected in series, EMF is equivalent EMF is equal to the sum of the individual EMF. And equivalent internal resistance is the sum of the individual internal resistance. Now let us discuss cells in parallel. So we are drawing, I'm drawing two cells connected in parallel. See, this is a cell of EMF E1. It is internal resistance is R1. Consider another cell, internal resistance R2, EMF E2. These two cells are connected in parallel. So they are connected across the common terminals. So potential difference across the combination is V. And you know, in parallel combination, potential difference remain the same, but currents divide. Current through the cell E1 is I1. Current through E2 is I2. So current through this two is I. So this I is total current, I1 plus I2. Parallel combination, potential difference across the combination of cell will be the same. And you know, for first cell, V equals E1 minus I R1. We can rearrange this. We can find out current. I1 R1 equals E1 minus V. So what will be I1? E1 minus V by R1. In the same way, we can write I2 for the second cell, current from the second cell, E2 minus V by R2. Now, what will be the total current? We have to add these two currents. So I equals I1 plus I2. Now we can put these values. I1 is E1 minus V divided by R1. I equals I1 plus I2. What is I1? I1 is E1 minus V by R1 plus E2 minus V by R2. So we can rearrange it as E1 divided by R1 plus E2 divided by R2 minus V into 1 by R1 plus 1 by R2. Now you have to take LCM. Take LCM and simplify. What we will get? E2, E1 R2 plus E2 R1 by R1 R2, first term. In second term, minus V into R1 R2 upon R1 plus R2. This is the equation for the internal resistance. Sorry, this is the equation for the current, total current. So I equals E1 R2 plus E2 R1 divided by R1 R2 minus V into R1 plus R2 divided by R1 R2. Now you take cross multiply by R1 R2. So now cross multiply, you are getting I into R1 R2 equals E1 R2 plus E2 R1 minus V into R1 plus R2. Now we can divide throughout by R1 R2, R1 plus R2. We can divide throughout by R1 plus R2. So what you are getting? I R1 R2 divided by R1 plus R2 equals E1 R2 plus E2 R1 the whole divided by R1 plus R2 minus V. Now we are rearrange this equation in the form of V equals E minus IR. So V take to the right side, the current term take to the left side. E1 R2 plus E2 R1 divided by R1 plus R2 minus I R1 R2 divided by R1 plus R2. Okay, this can be written as V equals E equivalent minus I into R equivalent. What is E equivalent then? E equivalent is E1 R2 plus E2 R1 divided by R1 plus R2. Okay. Similarly, what is R equivalent? R1 R2 by R1 plus R2. So when two cells are connected in parallel, what is equivalent EM of E1 R2 plus E2 R1 divided by R1 plus R2? When two cells are connected in parallel, what is equivalent internal resistance? R equivalent equals R1 R2 by R1 plus R2. Children, this derivation is very important for the examination point of view. Okay. If in case if the cells are connected in opposition like this, see, one cell is like this and another cell is like this. In this way it is connected. Then equation become E equivalent is, see here positive negative cells are both in the reverse order, right? E equivalent will be E1 R2 minus E2 R1 divided by R1 plus R2. Internal resistance will be R1 R2 by R1 plus R2. So children, derive it, learn it. Very important for examination point of view. Now, if n identical cells are connected in parallel, what will be the internal resistance? N identical cells. So all cells are having same EMF and same internal resistance. You know, parallel combination EMF remains same. So if n identical cells are connected in parallel, then what will be the equivalent EMF? it will be E only, because in parallel combination EMF is same, right? So EMF will be equivalent EMF is E. What will be equivalent internal resistance? Then you have to use this equation, 1 by R equivalent equals 1 by R. You know the equation for parallel combination of resistance, 1 by R plus etc. plus N times. You get N by R. So what is R equivalent? R by N. Okay. If a parallel combination of N identical cells is connected to an external resistance, okay, that parallel combination of cells is connected in series to an external resistance. What will be the current through that? Current will be then in EMF is E divided by external resistance is R plus internal resistance R by N. So we can write it as NE divided by, after taking LCM, we can write like this as R plus N capital R. So this is about cells in series and parallel. Okay. Okay, students. So today I end the class now. Thank you for watching. We'll see in the next class. Goodbye.